In this video, we are going to focus on other number systems. Okay, so we have studied about how we can convert from decimal to other number systems and vice versa. Now we are going to talk about binary to octal, binary to hexa, or vice versa. Yeah, that's what we are going to talk about. So how you can think about this is, okay, there are two ways to do this. Okay, there are two ways to do this, and I'm going to focus on one way in this video, which is like using a translator. Let's say you're going to an unknown country. Okay, let's say you are in the country A, and in country A they speak the language of binary. Okay, they speak the language of binary. Okay, and in country B they only speak the language of octal. Okay, so they only speak octal, and A in the country A where you're from only speak binary. Okay, let's say you have to communicate with B, the people in B. Well, what you can do is, okay, what you can do is you can either study the language octal. Okay, you can either study the language octal, or you two countries can agree on one thing. Okay, you both can learn a single language from another country. Okay, let's say that country is a universal country. Okay, so in this case the universal country may speak decimal. Okay, they may speak decimal, and what you have to do is, whenever you want to talk with octal, you can talk in binary, no worries. When you talk in binary, it will be converted to decimal, and that decimal will be converted to octal for people in B, and it will happen in the reverse process. When octal people are talking to you, okay, they will speak in octal language and it will be converted to decimal, and finally when it reaches you, it will be converted to binary. So this is the second method, and that's what we are going to focus on. Okay, I mean, you can directly speak octal and octal can directly speak in binary, but that's for another video because I need content. Okay, so let's only talk about this one in this video. Okay, so we are using decimal number system as the intermediary because we know how to convert to binary to decimal, we have learned that, and we also know how to convert from decimal to octal, we also have learned that. So we are going to apply that specific idea to convert numbers left and right. Okay, so let's start with an example. Let's say we have an example such that, let's start simply. Let's say we have 101. Okay, let's say we have 101 to the base 2. Okay, 101 to the base 2. Well, this is equals to, okay, 1 into 2 to the power 0, which is equals to 1. I'll just write them down directly. Plus, since we have 0, so 0 into 2 will be 0, so we don't have to write that. Here we have 1 into 4, okay, 1 into 4. So that will be equals to 5 to the base 10, okay, and you have to convert this to octal, yeah. So what you have to do is, you just have to divide it by 8. Well, if you divide 5 by 8, you will get 5, and you will get 5 actually, yeah. The remainder will be 5 because 0 and 5 will be the answer. So if you go from bottom to top, it will be equals to 5 to the base 8. Okay, so this is what's going to happen when you are converting from binary to decimal. So let's do another practice question. Okay, let's say we have 1101. Yeah, let's say we have 1101 to the base 2. Okay, so that will be equals to 1 into 1 plus 0 into 2 plus 1 into 4 plus 1 into 8. So that will be equals to 8 plus 4, 12, 12 plus 1, 13. So it will be equal to 13 to the base 10. And if you divide 13 by 8, you will get 1 and remainder 5. So if you go from bottom to top, it will be equals to 15 to the base 8. Okay, let's try another one. Yeah, let's say we have 1, 1, 1, 1, 1 to the base 2. Well, that will be equal to 1 into 1 plus 1 into 2 plus 1 into 4 plus 1 into 8 plus 1 into 16. So that will be equals to 31 to the base 10. So if you're converting 31 to the octal number system, you have to divide it by 8. So it will give you 3 and remainder 7. So from bottom to top you go, it will be equals to 37 to the base 8. Okay, and similarly, let's say we have 1, 0, 0, 0, 0, 1 to the base 2. Well, that will be equals to 1 into 1 plus 1 into 32. Okay, because this is 2, 4, 8, 16, and 32. So the answer will be 33 to the base 10. So that will be equals to 41 to the base 8. Okay, you can try this obviously. So 33 divided by 8 will give you 4 and remainder 1. So it will be 41 to the base 8. How did I do that directly? Well, I know 31 to the base 10 is equals to 37 to the base 8. So 32 to the base 10 will be equals to 40 to the base 8, because we know after 7 it has to be 1 added to the 8th place. Okay, 1 added to the 8th place. So 33 to the base 10 will be equals to 41 to the base 8. That's what I did here. Okay, so now we are going to do the vice versa. Okay, now we are going to do the vice versa. What is vice versa? We are going to convert from octal to binary. Okay, when we are converting to octal to binary, we do the same process but in reverse direction. So let's say we have 7 to the base 8. Well, that will be equals to 1 into 7. So it will be 7 to the base 10. Okay, so you have to convert from 7 to binary. So that will be equals to 4 plus 2 plus 4 plus 2 plus 1. So it will be 111 to the base 2. Okay, so if you want to check out what is the method I'm using without dividing, you can check the video that I have included in the description. Okay, so let's say we have another one. Let's say we have 15 to the base 8. Well, that will be equals to 5, well, 1 into 5 plus we have 8 into 1. So that will be equals to 13 to the base 10. Okay, so 13 to the base 10 will be equals to 8 plus 4 plus 1. Yeah, so 8 plus 4 plus no 2, so it will be 1. So it will be 1101 to the base 2. Okay, let's try another question. So let's say we have 27 to the base 8. Okay, so let's say we have 27 to the base 8. Well, that will be equals to 7 into, well, 1 into 7 plus 8 into 2. So that will be equals to 1 into 7 is 7 and 8 into 2 is 16. So it will be 23 to the base 10. Well, 23 to the base 10 can be written as 16 plus 16 means we have 7 left, so no 8. There will be a 4, there will be a 2, there will be a 1. So it will be 1, 0, 1, 1, 1 to the base 2. Okay, so let's say we have another question. Okay, let's say we have 37. Okay, 37 to the base 8. Well, 37 to the base 8 will be equals to 1 into 7 plus 8 into 3. That's it. So it will be equals to 24 plus 7, 31 to the base 10. So that will be equals to 16, 24, 28, and 30, 31 to the base 2. So it will be the 1, 1, 1, 1, 1 to the base 2. Okay. So this is how you are going to convert from binary to octal and octal to binary. Okay. You are going to do the same thing. Okay. You are going to do the same thing in hexadecimal also. So let's try some questions so that we don't make any mistakes. So let's say we have in binary we have 1101. Okay, so let's say we have 1101 to the base 2. Well, that will be equals to 1 into 1 plus 0 into 2 plus 1 into 4 plus 1 into 8. So it will be equal to 13 to the base 10. So it will be equals to 13 to the base 16. Well, we know we can't write down 13 directly. 13 will be represented by D. Okay, in hexadecimal, 13 will be represented by D. So it will be D to the base 16. Okay, so how did I convert it? Well, I divided by 16. Okay, if you divide 13 by 16, you will get 0. Okay, but the remainder will be 13. So if you go from bottom to top, it will be 0 and 13. So that's why I directly put D here. Okay, so let's try another question. Let's say we have 1, 1, 1, 1, 1 to the base 2. Well, we know this is equals to 31 to the base 10. Okay, I did this already, so I don't want to do it again. So let's just divide it by 16. So if I divide it by 16, I'll get 1 and 15. So if I go from bottom to top, it will be 1 and 15. I know 15 is represented by F. Okay, F. So it will be 1F to the base 16. Okay, 1F to the base 16. Now let's try another question. Let's say we have 101010. Okay, 101010 to the base 2. So that will be equals to, in decimal, it will be equals to 0 times 1, 1 times 2, 0 times 4, 1 times 8, and 0 times 16, but 1 times 32. So it will be equals to 42 to the base 10. And if I divide it by 16, I will get 2 and the remainder will be 10. Okay, so 2 and remainder 10. So if I go from bottom to top, I will get 2 and 10. So that will be equals to 2a to the base 16 because 10 is represented by the English alphabet A. Okay, you may think, why am I putting capital A here, uppercase A here? Why don't I put simple A here? If I put simple A here, what will happen is nothing will happen. Okay, nothing will happen. It's your choice. Use simple letter, use capital letter. That's your choice. Okay. But I was told to use uppercase letter for some reason. I don't know what the reason was, and I didn't ask. So it's your choice. Okay, it's really your preference. If you like up the lowercase letters, write it down. If you like uppercase letters, write it down. But only make sure you use one type of letter. Okay, if you're using uppercase, use uppercase. If you use lowercase, use lowercase. Don't be like this. Okay, F and A C and D E. Don't be like this. Okay, don't be like this looks bad. This actually looks bad. Okay, so either use all uppercase letters, okay, all caps, or just use all simple, all lowercase letters, F A C D E. Okay, keep uniformity and maintain tidiness. Okay, I know I'm not going to teach all these things, but just keep in mind. Why not? Yeah. So use one type of letter. So let's go to another question. Let's say we have 1 1 0 0 0 1 1 to the base 2. What will it be equals to? So 1 into 1 plus 1 into 2 plus no 4, no 8, no 16, but there is 32 and 64. I'll write them down directly, okay, because I'm going to multiply it by 1. So it will be 96, 98, and 99 to the base 10. So 99 to the base 10 can be converted to hexadecimal. So it will be equals to 6, and the remainder will be 3. Yeah. So 99 means 6 means 96. Yeah. You can go from bottom to top. So it will be equals to 63 to the base 16. Okay. So this is how you have to convert from binary to hexadecimal. You are converting it to decimal first, and then you are converting it to hexadecimal. Now, when you are converting from hexadecimal to binary, what you have to do is just the reverse process. Okay. First of all, they will give you the number in hexadecimal. You just have to convert it to decimal, and then you can go to binary. Okay. So let's say we have something like a to the base 16. We know a represents 10. Okay, 10 in decimal number system. So when we are going from 10 to binary, we can write down 8 and 2. So 8, no 4, only 2 and 0. So it will be 1010 to the base 2. Okay, so let's say we have 1f to the base 16. Okay, 1f to the base 16. So that will be 15 into 1 plus, because f holds the value of 15, and the place value of f is equals to 1, 16 to the power 0. Yeah. And then 1 holds the value of 1, and the place value will be 16 to the power 1, which is equals to 16. So that will be equals to 15 plus 16, 31 to the base 10. So 31 is equals to 1, 1, 1, 1, 1 to the base 2. Okay. And let's try another one. Okay, let's try another one. Let's say we have 2b base 16. 2b base 16. Well, that will be equals to b is equals to 11. So 11 into 1 plus 2 into 16. So 32 plus 11, 43 to the base 10. And that will be equals to 32, no, 16, 40, 42, 43. It will be 1010 to the base 2, not 3, 3 to the base 2. Actually, I don't know what the use of a number system 3. I mean, mathematics, there are number system. I mean, we generalize everything in mathematics. I don't know why we have number system 3, but I don't know. I know why we have number system 4 though, because they use in DNA. Okay, because there are 4 states in DNA, so they use in biology. They use the number system 4. Okay, number system 4. I think there is a special name for that. I think it's a quaternary or something like that. Quaternary number system. I'm not exactly sure, but I know they use for biology, and in coding they use this, encryption they use this. Okay, that's cool, but we don't study about that because it's very specific application. But I don't know whether they use number system 3. If you know, please let me know in the comments. We learn together. Yeah. And let's do our final example, which is ace, as we always do. So ace to the base 16. So it will be equals to e represents 14. So 14 into 1 plus, and c represents 12. So it will be 12 into 16 plus a represents 10. So 10 into 256. Why is it 256? The place value of a here is 16 to the power 2. So this will be equals to 14 plus 16 into 12 is equals to, I think, 192. Yeah. I think we did this question already. Yeah. Yeah. Ace. Yeah. So 192. Here we have 14. Here we have 192. And here we have 2560. So 192. So it will be 206 and 2766. So 2766 to the base 10. Well, this is interesting because if we are converting this to binary, it will be a long process. So I'll write this down here. So 2 to the power 10 is equals to 1024. I think we can include 2048 here. So 2048. So 2766 minus 2048 will be 2000. Yeah, 48 will be 718. 718 means we can have 512. So 512 is gone. So we have 206. So 206 means we can have 128. So 128, we have got 78. Well, 78 means we can have 64. That is 14. No 16. That is a 8. And for 6, we have 4 and 2 and no 1 to the base 2. Shall we check? So here we have 1 minute. Just erase it. So 2, 4, 6, 6 and 8, 14, 14 and 64, 78, 78 and 128 is 206, 206 and 512, 718, 718 and 2040, 8 is equals to 2766. Yeah, exactly. So this will be the answer. Okay. So if you have any doubts, please let me know in the comments because I have done the simplification directly. If you have any doubts, just go through the link I am giving you in the description. Even after that, if you have doubts, let me know. I can do. I was thinking of doing a live stream. Yeah, I was thinking of doing a live stream for everyone, and in this specific section because when you are doing questions in number systems, the practice is a very important. Okay, practice plays a major role. Okay, so that's why I'm asking you to let me know if you have any doubts. Okay, and yeah, in the next video, we are going to convert from binary to hexadecimal and hexadecimal to binary directly. Okay, directly. We are going to use a table to find the solution. Okay, so stay tuned. Why not?
Thanks for watching this 7th video in our number system series. If you found this tutorial on using decimal as an intermediate translator to convert between binary, octal and hexadecimal helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.